Hello everyone. I hope you are enjoying all the sessions being delivered at Azure Community Conference. My name is Manish Sharma. I work as Senior Technical Program Manager at Microsoft. I'm part of Cosmos DB engineering team. In this session, I'm going to take you through my experience uh, with with the customers who are basically looking forward for optimization from performance standpoint. All these demos are basically coded into .NET for the ease. But if you are Java developer or have understanding about different language and you need some specifics to be asked from me, you have all the contact details of mine flashed on the deck. Please feel free to reach me out. I'll be more than happy to help. The session is actually primarily discuss about the performance optimization best practices. However, I would like to give you an overview of Cosmos DB for a few minutes. Cosmos DB is a NoSQL service by Microsoft, and this service is actually multi-model and have massively scalable aspect. This service is actually providing various APIs. If you look at the first layer, is basically talks about the API. So we have table API, Cassandra API, we have Mongo API, Gremlin API, and have SQL API. So if you are coming from OSS background and you would like to go for Mongo, Cassandra, or Gremlin, you can go for it. If you are coming from table storage background, you wanted to have a all the functionalities being provided by Cosmos DB, but you still wanted to stick to your old code written for table storage, you can go ahead and use table API. If you are a RDBMS developer and you wanted to start afresh, you can certainly hook up to SQL API. This will help you utilizing your existing skills, and you don't need to have a learning curve before you. So we help all the customers, all those customers who would like to go for the existing skill coding. So what we also provide is basically the multi model. The multi model is basically providing you various aspects to store your data, whether it is key value data or it is column family data or document oriented data model. Uh, or if it is graph data model, you can certainly store it to Cosmos. So it's one-stop shop for all of your NoSQL requirement. In Cosmos DB, what we provide is basically we have turnkey global distribution. That means that you can literally scale to entire world. We are the largest service provider in the industry. So Azure has more than 54 regions, and those regions have Cosmos DB because Cosmos DB is the tier 0 service. Means that whenever a new data center is being launched, you already have that Cosmos DB as part of the basic service. Uh, Cosmos DB provides elastic scale out from in terms of storage or in terms of, so there is no limitation as such that how much you can scale from a service standpoint. um, we also provide you guaranteed low latency at the 99 percentile, and this low latency is basically for both reads and writes. We also provide file well-defined consistency because when you writing an application, your application might need some different type of consistency requirement. So we are providing more options that you can select a suitable option for your application. And let's look at what are the different features we have. Um, so as I think I've already mentioned, one thing I just wanted to highlight in turnkey global distribution, We support both one read, one master, multiple slaves, and we also support multi-master, so that you can write anywhere, write read, in any region, and there is no limitation that how many number of regions you can have. As long as you have access to Azure data centers, we are completely okay to enable the replicants for you. We have support for schemaless architecture, so which means that you can push your person document, or you can push your cat document in the same collection, and there's no problem as such. In fact, it will actually give you a flexibility to define indexing also. So indexing is completely dynamic. So the moment you push the data will get indexed, and the second moment you have the possibility to query, and query performance will be much better if you are basically performing all the indexes. We provide you enterprise grade security, which means that we provide you encryption at rest at encryption of transit. We have default, which is basically enforced 256-bit key for your database account accessibility. We have compliances applicable to Cosmos DB. So we have PCI, SOC 1, SOC 2, SOC 3. These are named few. You can go to Azure Trust Center and download the audit reports for Azure Cosmos DB's compliances. Um, Now let's switch the gear. What we have a problem statement is the high latency. The customer is asking that, hey, uh, we did a load test, and it comes out to be that it's not performing as per our requirement. So they shared some numbers. So these are sample numbers, and you can see that these are pretty weird. So 200 millisecond is too high, and 5 second is like it's not Cosmos TV. So what are the challenges customer had in terms of improving the performance? So that I'm actually going to discuss. So this is the architecture, deployment architecture look like. It's pretty simple. Load test server is there. You have AKS cluster. You have Cosmos DB instance, and they are all connected to each other. Environment, again, pretty simple SQL API they were using, and they are using .NET V3 SDK. AKS is there. Their expectation was less than 50 millisecond, and the number of RUs they have specified is 9,000. RUs are basically nothing but request units. You can consider as your transaction per. So it gets translated directly from transaction per second to request unit. You can think of okay. So I think I'll brief you a little about this cost factor. So in Cosmos DB, how you pay is basically you have two meters. One is you have storage, which is per GB per month, and then you have request units, which is a compute. So what you do is basically you go to capacity calculator. One second, let me just push it that so that you'll have better clarity. So this is a capacity calculator, and I highly recommend that you should click on the sign in so that you'll get more options. So once you click, you will actually have more options available. Right now, it is available for SQL API and Cassandra API, but we are working on to add more APIs. You can specify the number of regions. If you wanted to go for multi-region, right? You can just specify. You can choose the consistency model, indexing policy which you would like to go for, how much data you wanted to store. So all these factors are actually impacting your cost. And then one of the most important factor is basically how many number of reads you wanted to go for, how many number of creates, updates, and deletes. and then you specify the size of your document which you wanted to perform CRUD on. Once you do that, you actually be able, once you click, you can click on it, and then this guy will actually give you more details that how many number of throughput you need for reads, how many number of throughputs you read, creates, updates, and deletes. So this is in terms of number of RUs. This is just an indicative figure because you have specified this input. That's why you are basically getting this. End of the day, let's say if you identify that, hey, I wanted to go for 843 RUs. This means that these 843 RUs are being flexible. You can utilize in any fashion. Like you can use it for more reads, less write. You can use less, writes, less reads and more writes. So you can choose anything, whichever you feel comfortable in, and then you are going to pay for that. So now coming back to our discussion about the RUs, so they have specified the length for their workload. So number of users they have configured in their test environment is 500 users per second. Where the bottleneck would be. So, in my opinion, we should investigate everything. We should start investigating from load testing server, the problem areas in application, problem area in connection, problem area in Cosmos DB. So we can just verify everything. So let's look at different aspects. So what was the wrong with let's say I'm performing some tests. So what is wrong with it? What can go wrong? Skewness. The problem is sometimes we forgot to generate the uniform data. Sometimes the data generation is completely different from the actual environment. That ways, your results will be, coming to this, skewness. Let me show you with an example. So let's say if this is an Excel file and I'm generating two columns, one is ID and second is partition key. And if you look at all of my data actually belong to same partition key, and very few records I just added for other partition key. This is bound to happen. Like you will have hot partition. Now folks who don't understand this chart is actually provided by Cosmos DB's portal experience. So you go to metrics, you open Azure portal, go to metrics, and then go to throughput tab, select your collection. This guy will actually popped up. If all green means you're sorted, you don't need to worry about. But if it is not, then you see any shade of red, you will actually needs to look at your partition key strategy or your data distribution. So this was very bad in my case. The customer is actually was not able to generate the data uniformly. Hence, they were getting a lot of skewness. Skewness actually creates trouble in terms of skewness of your RUs, skewness of your throughput. So I think it's a one of the a culprit for not providing you the performance you are looking for, or the performance you have configured a cache Cosmos DB for. Second point which I would like to highlight is basically single execution of test. So generally, it's a tendency that I've seen across various customers that when you wanted to perform load test, what you do is you configure Cosmos DB, you immediately bombard your load and then come back. I think it's not good. So what you need to do is you need to configure Cosmos DB. Then you need to you are you can bombard, but don't capture it in the first few executions. So what you can do, you can skip at least two execution, and then from third execution onwards you can basically pick up start capturing the numbers. So that's one of the important thing I just wanted to share. I'm sure that you might have already taking care of this best practices. And this is not related to Cosmos DB. This is for any application which you would like to go for, from load testing perspective. Then I have laundry list for client side. So this client side list, I'm I would like to just highlight, point by point. Client objects. First of all, client object has to be static for us. Cosmos DB recommend that you should have singleton instance for your Cosmos DB client object. Why? Because this guy is basically requiring a lot of metadata to be captured. So every time you are performing the activity, you end up acquiring a lot of metadata, and it causes a lot of latency. So maybe you can go for singleton. Yes, you can go for it. And how about thread safety? If I'm creating multiple threads and using the same connection object, is it performant? Yes, it's performant, and it's completely thread safe. I know that it's completely against to what we were seeing in RDBMS world or some other NoSQLs, where you instantiate in every request. So in case of Cosmos DB, there's no need to do that. So let's look at the difference between if you instantiate what happened and if you don't instantiate what. So I mean per request. Yeah, so if you go for this code is pretty simple. So you have connection object, and I'm just iterating through, and then you're creating an instance in every iteration, and then you're picking up the amount of time it takes to read the document. In case of static, I was just creating a static connection object. I'm just iterating, but I'm not initializing. So this is a pretty simple demo which I would like to uh, demonstrate. So let's look at what the performance look like. So let me So I'm instantiating on every request. That means that it's taking double-digit millisecond, and it's going down, but still, bit high. If you look at the static connection, yes, initially it was higher, and then it actually goes down in less than 1 millisecond. These are just noise. You can ignore that and just pick up P99. So in case of P99, you should be able to get single digit milliseconds very easily. So this is the demo from a perspective of static connection or singleton connection. Okay, so coming back to our slide deck. Now, second point is um, our query. So basically, when you're writing a query, of course you can. So Cosmos DB supports query, and then we have an operation called read. So in case you have a requirement where you are saying that, hey, I'm planning to use ID and partition key in my query. Shall I use continue use the query? The answer is no, you should not. Um, so what you can do, you can actually, so let's say if you are performing this query, something like this, let's start from C where C.id equal to something, and your region is something, and region is your partition key, for example. Then what is recommended is you can look for read. This read operation, read item async, requires you to specify ID and requires you to specify a partition key. In this case, there's no overhead on indexing, and then you directly reach to the document and get the document. The cheaper operation, it will give you the faster response time. Let's see if it is how much faster it is. So let's have a demo for that. So we can just say, okay. So if you look at the query execution time, it's taking like 15 milliseconds, 6 milliseconds, 16, 4, and the query cost is basically 2.98 RUs. Let's see how much lookup will take. Okay, so lookup is taking somewhere close to 1 millisecond, and then it's all 1 millisecond, and then cost is almost less than half. So this is basically the power of lookup. So you can go for the lookup if you are having ID and partition key in your query criteria. I hope this is making a lot of sense. Um, okay, so let's see if we. Okay, so now connection mode. So we actually provide two type of connection mode. One is a gateway connection, and second is uh, direct connection. So in case of direct connection, we directly approach our partitions, and you will be able to consume data directly from there. However, you need to open all the ports, like 10,000 to 20,000 ports. Yeah, port numbers. You need to open those ports. If you have a restricted environment and you think that no, my firewall is very restricted and I can't open it, then there's a gateway mode available. However, it is a recommendation that if you are utilizing, if you are very sensitive about the latency and you're utilizing the partition key in a distributed manner, and you're basically performing async jobs, then you should not use mode. You can go for the connection, default direct connection mode. What does that mean? So let me take you through the code piece. So if you look at this code is having only small change. Um, I'm using the best practice now. So I have connection mode as direct, which is says direct connection mode, and then have gateway connection mode. However, because I have very small data set, so the impact is not very high. It is a minuscule amount of impact you can see here. However, in case of your environment where you have larger TPS and you have higher distribution, then you'll see really a difference in performance. So let me take you to the uh, demo. So you can see. So if you see here, it's taking somewhere close to 3 millisecond to 3 millisecond time frame. And then if we look at the gateway, so it's actually, sorry, connection mode equal to direct, it's actually taking 1 millisecond. In most of the cases, it's 1 millisecond. So the difference is primarily that it directly reaches to the relevant partitions and get you the data. That way, it will be much faster. However, there is no impact in terms of RUs, and the cost is not there. However, the latency, will be improvised drastically. So that's the point of connection mode. Network pipe was public. Okay, this is very critical. Now, the point is, in most of the enterprise is requiring a very stringent level of security. So let me take you through what is the configuration look like for the um, private endpoint machine. If I can minimize, because I can't demo on the public machine. I need to go for separate machine where the private link is configured. So let me take it to portal. In portal, Cosmos TV, we have private endpoint and virtual network support. Virtual network support. Um, and then what you do is basically you deploy your application, your Cosmos DB onto the virtual network, configure a private endpoint, and then they deploy your application onto the virtual network, application server onto the virtual network, and then you access via the private endpoint. So private link endpoint. So here in my firewall and virtual network, you can see I have configured this virtual network, and this virtual network has endpoint status equal to enabled, and this is my private endpoint connection where I'm having connection state as approved. Now Other than this machine, nobody else will be able to access until unless they are part of that virtual network. So that's why I came all the way to this particular machine. So let's look at this. Um, Private endpoint is 4 number. To look up execution, so it basically you can see that it's actually reaching to 0.9, 0.80, and this is basically you have pretty good performance from a standpoint of Cosmos DB, because how you are able to get the better performance, because you have single hop, very few hop, and those hop is actually not going to internet at all. I mean, it's a completely private endpoint. So this is certainly you will be able to get more performance, and security, because it's very secure. I mean, primarily basis, quietly secure. Um, Now, what I did is, in case of private network, from code standpoint, there is no nothing I have done. I actually I just picked up the Cosmos DB, which is deployed on the virtual network, and I have configured a private endpoint. Nothing else I have changed. So from a code standpoint, I have not changed anything. So I'm just using the plain vanilla same code which I have demonstrated for other public endpoint perspective. Now, if I look at this, another important aspect is basically more number of thread per core. Again, it's a very specific to the programming language. Let's say if you have more number of tasks, and you have less number of cores, this will bound to give you thread switching. Means that thread switching is required, because let's say if I go, if one thread is actually waiting for IO, then second guy is actually getting the prioritization, and then you need to come back, into the critical section when you got the response back. Now this switching is actually caused sometime higher latency. So what you actually need to do is you need to increase the number of cores, and once you increase the number of cores, you'll actually be able to get the better performance. To demonstrate that, I'll basically use my machine and my server to compare. So my machine is having 8 core, but 8 cores is like uh, almost 60-70% can be used. So if I go for uh, threads per core, I'm just doing 4,000 execution together, and this is task.when all I'm actually going to perform. I'll brief you in the next point that why I'm doing this, because it's a asynchronous thing. So I'll talk about it. So let's execute this. This is my machine, so please expect a horrible number. Okay. Oh, sorry, I think I have pressed the wrong key. I should press 5. Okay, I should press the 5. Yeah, as expected, it is taking time. So let me do one thing. Let me just switch to my public server, and let's execute here as well. So 5 is the demo. Okay. So it took somewhere close to 230.4718 millisecond for all the iteration. For 4,000 iteration, it took just 230 milliseconds. Because this guy is having 16 cores, and my machine took a very horrible number. Um, yeah, this is basically a kind of high level demo for your thread switching. But yeah, so you can think of parallelizing, but make sure that you're not overly busy your number of cores. So make sure that you should have enough number of cores you have at your disposal so that you'll be able to get the um, room to execute threads. Now, let's look at this last concept for the client side. So async performance capture, sometimes very important. Now, there are two ways to capture the performance. One, you wanted to capture for per request. When you wanted to capture for per request, then you should go for blocking. So you can use a blocking thread and then you capture the per request latency. But if you wanted to, if your concern is that hey, I have a batch of some 4,000 iterations, I wanted to basically or 4,000 operations, and I wanted to execute then asynchronously. Then what should be my performance number look like? So I should wait for when all, and then I'll basically use start time minus end time calculation. So let me see if it is yeah, ready. I think it's ready. So okay, so let's press 6 because this is 6 demo. Okay, so per second it is take per operation it's taking like 58 millisecond, 54, 53, something like that. But if we use the 4001, let's see how much time it takes. I think now it is started. So it took somewhere close to 10,234 to execute 4,000 operations, and it took 2.5 millisecond per iteration. I think this is how you capture your asynchronous jobs. So this is these are all from standpoint of the client. Instance. Now let's look at the data model itself. So sometimes you have perception that hey, let's say you have Cosmos DB as a NoSQL, and NoSQL we always go for denormalized. The answer is no. You should think about slow changing dimension, fast changing dimension. In short, it's called SCD and FCD. If you merge both type of dimensions, of course, you are end up consuming a lot more number of arguments, and you will have a lot of latency. How? Okay, I'll take an example of employee object and attendance object. So let's say you have an object of employee. Maybe few information will have for employee like name, region, it belongs to ID and department. These are seldom change. And every day I need to capture employees. That's business as usual. So if I need to do that, if I'm just merging both the aspects, this model is actually what give you the sense. Second model could be I'm splitting, like I'll create an employee object separately, and then I'll create multiple employee attendance object on a per day basis. Whenever somebody is entering, I'm basically capturing employee attendance, not related to, not going inside the employee object. One thing I'll be able to get is basically every time I'm inserting the attendance object, I know that attendance object will remain same. In case of this model has a problem that every time you are basically adding an attendance, you are actually adding attendance into the same document object. Anywhere, wherever you go, like if there is any document data model, they always have a maximum limit how much you can store. And every time you add the data, you actually increase the size, meaning that whenever you're performing any operation, the cost of operation will be high. Uh, what is the best practice? So keep it separate. Let's see if, with the help of some demo, let's see if we are able to see it. Um, what do we have? I called it, it's a, upsert insert demo. Let me just clear the stuff here. So if you see this carefully, so upsert is taking 12.195 RUs and insert is taking only 7.43 RUs. This upsert will actually um, be worsen. It actually day by day it actually increase the cost and the latency, because it has to upset the document. In case of second model where I'm just adding a attendance, I'll have constant attendance information in terms of the size of the data. Data inside that will get changed. And then I'll have 7.43, 7 RUs, 7.5 RUs is the is the figure which I'm going to charge on a daily basis. When I'm retrieving, I know I can just pick up a specific piece, and I just need to pay for that specific piece. Nothing I need to worry about. Again, the importance of is you have a scalable aspect, like you can store the attendance of the employee like for maybe 10 years, and there is no problem with the size of it. So document size will not have any concern. Performance will be better. The cost will be better. So I think it will be easier if you can, you pick it up. Now, one perception I'd like to also clear that how about getting, fetching all the data? If you're fetching all the data, you can better fetch with the split of data, because then you can have multi-threading in your application and you can execute it together and then merge it into your application. Wherein in case of the bulky document, you actually wait for that bulky document to travel from network to your environment, and then you will be able to perform some activity on top of it. I hope it makes sense. Um, Now, um, what else we have? Uh, Binary files. Yeah, this is important. That let's say if you are planning to upload images, don't upload images onto database. I understand that some of you might be wondering that in on-premise world, in some of the databases which support images, I used to upload the binary files. But in case of cloud, it's not a very wise decision. In fact, in RDBMS SQL Server also have a recommendation that the file should not be uploaded onto the SQL Server. You can use blob storage, which is far cheaper, and then have a reference into inside the Cosmos. That you can certainly do. That way, you will be able to manage both your cost versus scalability. You can easily do that. The current database is on the right place for storing such binary files. Um, these are the aspects I had from perspective of performance. Uh, what was the final result we got from our engagement was this. So you have seen the figures was mostly in seconds, and had the best was 3-digit millisecond, which is too high. And end of the day, what we have got is somewhere close to single digit millisecond latency that customer was able to achieve, and he's superbly happy with the results now because their expectation was double digit, but we were able to reduce it to single digit. That was our engagement's outcome was. So not only in terms of read items, but also in terms of query items. I would like to highlight that query is not always bad. It's just a use case. So when you think that you don't have ID, you don't have partition key, when you don't have partition key, you always perform cross partition. So cross partition is not bad in terms of performance, but in terms of cost, yes, it will be higher because then it has to go to all the partitions and come back with the data. Um, and then we have in terms of query, so what you do is basically you have terms. For example, let's say you have some fields which you wanted to query your data in. You can perform those queries onto Cosmos DB very easily. One thing I would like to highlight that some point of time that you might be wondering that, hey, so this is our playground where you can perform all your sandbox queries and all those queries very easily. There is no limitation as such, and you should be able to quickly do hands-on on top of it. These are canned queries we have already provided. Just in case, I mean, we have user-defined function, we have built-in functions, we have join, we have projections, we have in and between, we have a lot of out of the box functions. You can execute all without you spinning up the instance and creating sample document around it. You can certainly perform the stuff here. That, yeah. You can also perform queries into geospatial. We do support geospatial natively. We do have sandbox as well, so you can run your own custom queries and you can be master of it. Um, that's one important thing. In case you wanted to go for something very specific in terms of cost, you can actually take two aspects of it. One is, let's say if you have variability in your workload, for example, peak and off peak, you can actually configure peak and off peak here itself. Get the information that what is the cost look like when I'm having peak and off. How do you peak and off? I mean, how do you switch from peak to off peak? You can easily do that using auto scale. In this scenario, when I was working with customer, 9,000 RUs was not fixed RUs. They were actually utilizing auto scale RUs. In case of auto scale, what we do is we ensure that whatever you specify as a max, from min to max, you will not get the throttling. And before we execute the query, actually bump up the number of RUs here. We execute a query and we come back to the normal. So the charge, from a charge standpoint or from a perspective of a fluctuation of your RUs from up and down, it's a millisecond job. So there is no time wastage you will have. So you'll not find that, hey, Manish, my use suddenly spiked and I'm not able to scale out. That's not happening possibly. So the moment you have the spike, will be able to handle the spike. And considering that you have given us the upper limit. So whatever upper limit you provide us, will be charging you one tenth of it. Like let's say if you specify 4,000 RUs, we are going to charge you for 400 RUs at a minimum, and then we can reach to 4,000 RUs at any given point of time as soon as your workload kicks in, and within 400 to 4000 RUs, you'll not find any throttling that's our guarantee. So that's that's one of the things which um, our customers are using very often, and then they are able to save their cost, and they are able to handle the high throughput bus very easily. Um, okay. So we have I think these are the communities we have. Which are basically very active, and these communities are there. Thank you so much for joining the session and spending your time. I hope I was able to at least scratch the surface. I'm sure that I was, I was having a lot of untouched points which are further, needs scaling, needs discussion. I'm sorry. So if you want, you can actually go to Azure Cosmos DB, um, docs, where we have optimization in terms of cost performance as well. So let me just project that. A second. So here you go. We have this article which is applicable for V3, V2, Java, and you can just pick and choose all the recommendations whichever we have discussed in some of the form. It's already there. Some of the things still are learning and keep updating it. My demos, I'll certainly publish my demos, and you can download and you can utilize from GitHub. And then feel free to reach us in case you need any help, and you find out that you have any specific point which you would like to discuss. Certainly, we are available. I think for ease, I'll do one thing. Let me put my contacts. Uh, I think I have it on the first slide. Yeah, these are my contact details. You can just note it down. You can reach me out for any further help. One last thing, just summarization that what Cosmos DB is. The notion of NoSQL came in because we want to have performance and we want to have scalability, and that's the basic notion of Cosmos DB. In Cosmos DB, we have unlimited scale, storage, unlimited scale in terms of throughput. We also have performance, and that's a guaranteed performance we are giving. And then what you expect from us is basically, uh, the lowest latency, single digit millisecond is it from reads and from writes perspective. If you have queries, you can certainly look at the query diagnostics to understand that uh, we need to look at. One of the important thing, if you find out that you have double digit millisecond, you're performing reads, right? Then you should investigate that. Most of, if you look at all the best practices and you try to implement it, I'm 100% sure that you will be able to achieve your right goal. And thanks a lot. Thank you so much for joining. Have a wonderful day, and I'm open for questions now. Please feel free to post your questions. I'll be more than happy to address all the questions whichever you have. Thank you so much.